Hey everybody, we're going to go over series circuits. Now, there is a difference between series circuits and parallel circuits, and it mainly has to do with the connections of the wiring to the components on the circuit itself. Series circuits are all in line. That means that they're all connected. Okay? You start off with your battery, and there's one continuous wire that runs all of the components. This is a light bulb. Runs all the components, and it's always in line. That's the key term, in line. The electricity flows through the wire, through the different components in this continuous cycle. There's no branching. There is only a line, in line. I think of series circuits as when you go to a fast food restaurant, right? Fast food place. You go to Whataburger and they have a drive through. Those vehicles are all in line. Okay, so there's your little drive through. Here's one vehicle. Here's another vehicle. There's another vehicle. There's no branching. They're all in line. They're all connected. Okay, that's the idea of a series circuit. Now, series circuits is where there's only one loop of wire and all the components are on it. That's your official definition. Okay? Everything's connected in line. If I had all of y'all hold hands, right? And you made a giant chain just of people holding hands, that right there is a series circuit. Okay? Now here's some rules for series circuits. Current, which is the flow of electricity, is constant in a series circuit. Charge flows through the circuit like water flows through pipes. Okay? Charge is the movement of electrons, right? In this case. So just like how water will move through a pipe, electrons will flow and move through wire. You know that wire is made of metal. Metals are conductors. Conductors allow electricity to flow. Without that, there is no current. So electricity flows through wires, and just like water, right? It's going to whatever or however much comes in is however much will come out. In this case here, the example, the amount of water or charge is the same at the entrance and as it is at the exit, right? So just like with water, however much comes in is going to be the same amount going out within reason. So resistors oppose flow of electric current through the circuit. Use this equation to calculate total resistance. All you got to do is just add up the number of resistors. Well, first off, what's a resistor? A resistor is what it says. A resistor opposes the flow of electricity. It resists the flow of electricity. And on a circuit diagram, all you got to find are the squiggly lines. This is a resistor. Squiggly line, squiggly line, squiggly line. Those are resistors. You put R1 to designate resistor 1, R2, resistor 2, R3. You get the idea. You can put as many resistors as you want. You know, the world is your oyster. But all you got to do in a series circuit is simply add up the overall resistances for each one. And then the unit that you will see for resistance. Because let's say this one has 10 units of resistance. So R3 has 10 units of resistance. What's the unit going to be? The ohm. Okay? 10 ohms of resistance. That's how you would refer to it. R3, 10 ohms resistance. And this could be a different number, but you get the idea. So these are some of the basic rules. Current is constant. Charge flows through the circuit like water flows through pipes. Resistors are going to oppose the flow of that current as it moves through the circuit. Cool. I'm going to erase this. There we go. So here's some true facts about series circuits. The current is the same at all points of the circuit. I start here, the positive terminal. Electrons are going to flow and move through it from high to low. Positive is high, negative is low. And just going to keep on flowing, high to low, high to low. And they're going to go through these components. And at any given point, the current is going to stay the same. Same current, same current, same current. You get the idea. Number 2, the voltage across each component will be different. So what are components? Those are the things that you can add to a circuit. Circuits are really cool because you add a variety of components on them. You can do cool things with them. Cell phones, computers, the ATM machine, everything that's electronic runs on a circuit. And you can design circuits and put cool components and do special things, special tasks. So it's very important to understand that the voltage across each component that you put in line on a series circuit is going to be different. The voltage is going to be high up here and low down here. It's going to cross through the component, the current, right? It's going to cross through, and you will have a change or a difference in voltage as a result. Okay? So voltage across each component is different. Multiple resistors can be put in series together. This is the proof right here. Starting off with the flow of electricity starting at the positive terminal, it's working its way through 1, 2, 3 resistors. You can add multiple resistors onto a series circuit. And all you got to do is just add up the resistance overall. Congratulations. You've done some math. Now, resistance in series. R EQ. Equivalent EQ, resistance R. Equivalent resistance is equal to R1 plus R2 plus R3, and however many resistors you have. All right, this is just a general formula. There you go, dot, 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 to tell you it doesn't have to be 3. It could be more, it could be less. But here's your practice problem. What is the equivalent resistance of two 10 ohm resistors in series with 3 2 ohm resistors? So your solution, remember the formula for combined resistance of resistors in series. Well, here it is. The equivalent resistance is equal to the total amount, right? The sum of each resistor that is in that circuit. In this case, I have two 10 ohm resistors, and I also have 3 2 ohm resistors. So all I got to do is add each of these up, and congratulations, I've got the equivalent resistance. So here's what I'm going to do. I have two 10 ohm resistors, so 2 times 10, plus I have 3 2 ohm resistors. You see what I've done here? 3 is the number of resistors, 2 is how much resistance each one of those has. I'm going to multiply those together, add them up, I get 26 ohms. That's my equivalent resistance. If that's too high speed for you, you could have also just wrote them out like this. 10 ohms. 10 ohms. I had 2 of them, right? 1, 2. 3 2 ohm resistors. 2 ohms, 2 ohms, 2 ohms. Same thing. Add them up. 10, 20, 2, 4, 6. 26 ohms. Done. So more than one way to skin the cat. All you're doing in resistance series, just add them up. So in this case here, I have another example of a series circuit that's in line with 3 resistors connected in it. I've shown you the electron flow, right, the current, and it says here, a series circuit has all the components connected on the same line as each other. Here you have 3 resistors, R1, R2, and R3. They are connected in series. They're in line with each other. And there's a battery. How do I know this is the positive end? You see this line is longer than this line. Longer line, positive. Electron flow, current, is going to go from high to low. Positive is high, negative is low. Then it has to jump across and reset the whole thing again. Okay? Resistors are going to act like rocks in a water pipe. All right? So you got a a pipe, it's got full of water, and you turn on the flow to it, water goes no problem. Turn off the water, stick a bunch of rocks in there and sand, and then what happens? You cut off the flow. It doesn't want to flow as easily because the rocks are resisting the flow. In a wire, the metals, as the electrons are moving through, they're bouncing off of each other, they're bouncing off of the metals, they're bouncing off of stuff, and that resists their flow. It slows them down. You heat up the metal, the wire, congratulations, you're going to increase the resistance because now the wire is starting to vibrate and everything's moving even more. So it's even harder to move and get all those electrons moving and flowing through. You could also have a wire that has a really small diameter and there's not enough space. That's a form of resistance too. You want more flow, get a bigger wire and don't have a lot of stuff resisting the flow. All right? But for series, all you'd have to do is add them up. In this case here, say that R1 was 5 ohms, R2 was 3 ohms, R3 was 7 ohms. Add them up, you get 15 ohms total resistance. That's that equivalent resistance thing. Now let's talk about current. Current is the flow of electrons through a circuit. In a series circuit, the current is the same at all points in the circuit. Sounding familiar? Repetitive? It should be. We measure current with an ammeter. An ammeter is going to be directly connected into the circuit itself. It's built in, it's in line. That's going to measure the current. It's the only thing that we use that's directly in line with the circuit. That's 2 test questions right there. Okay? Ammeter measures current. It's directly connected in the circuit. Now, let's talk about batteries and cells. Cells in series circuits. A battery is basically going to be made by taking cells and joining them together. V1, V2, V3, these are cells. You add them together, congratulations, whatever their overall voltage is what your battery will be, right? People have taken apart the little batteries that you put in a remote control, right? Like a AA or a AAA. And you'll notice inside there's little cells, and those are all in line, and that's what makes your battery, right? So a battery, as I've said, you take cells, you put them together. This picture shows a battery with 3 cells combined in series, so they are what you call in line with each other. They're all connected. Positive, negative, positive, negative, positive, negative. Put a case around it, make one side positive, make the other side negative. Congratulations, you got yourself a battery. Pretty ingenious. You can calculate the total potential difference by adding the voltages from each of these guys together. So for our example, just add up the voltage of V1, V2, and V3, get the overall voltage. Now here are your key features for a series circuit. All components are attached in a row. The current is equal everywhere in the circuit, and the voltage across each component is going to be different. Now, remember that whatever that voltage difference is overall across all the components in your circuit, when you add up all of those together, the sum of those voltages across each component is equal to the total battery voltage. So if you had a 9-volt battery and you ran that 9 volts of charge through all your components, and you calculated each component and said, okay, this component 2 volts, this component 3 volts, this component whatever, right? When you added them all up, they're going to equal or be similar to the total battery voltage. In that case, it was 9 volts. Okay, that's the idea. So this covers it. I just want you to make a copy of what you see here. Put this in your notebook because trust me, you're going to need this. Okay. Next time I see you, we're going to do series circuits worked problems. Okay. And then we'll start branching off into parallel circuits. So thank you for your time. I hope you have a great day.